All, today we are going to see about TCP/IP protocol architecture. TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. It was developed by US Defense Advanced Research Project Agency DARPA for its packet switch network or FANET. Was designed and developed by Department of Defense in 1960s and is based on standard protocols. It stands for Transmission Control Protocol and Internet Protocol, and it is a condensed version of OSI model. It contains 4 layers unlike the 7 layers in OSI model. The number of layers is sometimes referred to as 5 or 4. Here in this you are going to see about physical layer, data link layer, application layer and internet layer. So what does TCP/IP do? The main work of TCP/IP is to transfer the data of a computer from one device to another. The main condition of this process is to make a data reliable and accurate so that receiver will receive the same information which is sent by the sender. To ensure that each message reaches its final destination accurately, the TCP/IP model divides its data into packets and combines them at the other end, which helps in maintaining the accuracy of the data while transferring from one end to another. So let us see the difference between TCP and IP. The TCP and IP are different protocols of computer networks. The basic difference between TCP, that is Transmission Control Protocol, and IP, Internet Protocol, is in transmission of data. In simple words, we can say it as IP finds the destination of the mail and TCP has the work to send and receive the mail. UDP is another protocol which does not require IP to communicate with another computer. IP is required only by TCP. This is the basic difference between TCP and IP. Let us see how this TCP/IP model works. Whenever we want to send something over internet using TCP/IP model, the TCP/IP model divides data into packets at the sender and the same packet have to be recombined at the receiver end to form the same data, and this thing happens to maintain the accuracy of the data. TCP/IP model divides the data into 4 procedures where the data first go into this layer in one order and again it reverse order to get organized in the same way at the receiver end. The main layers of TCP/IP model are application layer, transport layer, network or internet layer, data link layer and physical layer. The physical layer lies the interface between data transmission device, example computer, and transmission medium or network. The characteristics of transmission medium is it receives the signal levels and also the data rates. It is a group of applications requiring network communication. This layer is responsible for generating the data and requesting connections. It acts on the behalf of the sender and the network access layer on behalf of the receiver. Next one is network access layer. The network access layer acts as a layer parallel the function of OSI network layer. It defines the protocols which are responsible for logical transmission of data over the entire network. The main protocols residing at these layers are IP, that is the Internet Protocol, ICMP, that is the Internet Control Message Protocol, and ARP, that is Address Resolution Protocol. It invokes the service like priorities. Next one is the Internet layer. Internet layer is the Internet Protocol suite which is set of protocols that define the Internet and is responsible for routing packets of data from one device to another across the network. It does it by assigning each device a unique IP address which is used to identify and device and determine the route that packet should take to reach it. Next one is the transport layer. Transport layer mainly used for easy delivery of data. Here, the exchange data receives acknowledgements and retransmit machine packets to ensure the packet arrive in order and without error. The end-to-end communication is referred to for that. The transmission control protocol and the user diagram protocol or transport layer protocols at this level. TCP applications can interact with one another using TCP as though they were physically connected by a circuit. TCP transmits data in a way that resembles character by character transmission rather than separate packets. A starting point that establishes the connection, the whole transmission in byte order, and the ending point of that closes the connection make up this transmission. UDP. The datagram delivery service is provided by UDP, the other transport layer protocol, and this connection between the receiving and the sending host are not verified by UDP. Applications that transmit little amount of data uses the UDP rather than TCP because it eliminates the process of establishing and validating the connection. And the last layer is the application layer. This layer is the analog to transport layer of the OSI model. It is responsible for end-to-end communication and error-free delivery of data. It shields the upper layer of the application from the complexities of data, and it consists of three main protocols. They are HTTP and HTTPS. HTTP stands for Hypertext Transfer Protocol and is used by World Wide Web to manage the communication between web browser and the server. HTTPS stands HTTP Secure. It is a combination of HTTP with SSL, that is a secure socket layer. It is efficient in cases where the browser needs to fill out forms, sign in, authentication and carry out bank transaction. SSH stands for Secure Cell. It is a terminal emulation software similar to Telnet. The reason SSH is preferred is because its ability to maintain the encrypted connection. It sets up a secure session over a TCP/IP connection. And last one is the NTP. NTP stands for Network Time Protocol. It is used to synchronize the clock on our computer to one standard time source. It is very useful in situations like bank transaction. We can assess the questions by asking what is physical layer, what is the purpose of application layer, and explain about network access layer like this. Thank you.